Without water, people will die. That's what may happen in places like Cape Town, where drought is ravaging the city. We would have no crops without water, and we can't survive without it more than a few days. We need water to maintain good hygiene, cleaning our environment and ourselves.
When we finally do get water, it can be in the forms of cyclones and hurricanes. Floods attack many regions of the world, most tied to the heavy monsoon rains. This is mostly water that we cannot drink. In some occasions, people would stare at the ocean, a massive body of water covering 71% of the Earth's surface, and wish they could drink it. To help with the fickleness of water, people have developed various methods to desalinate water. Desalination means getting rid of all salt in water to make it drinkable. One of the methods is reverse osmosis desalination process. This is basically where salt is removed from water by a specific membrane that only lets the water through. And here's where the math finally comes in. Look at this equation.
This equation shows the water flux, the rate at which water flows through the membrane. This equals A, the measure of a material's capacity to move water, multiplied by the difference between delta P, the gradient of pressure across the membrane, and delta pi F, the effective osmotic pressure gradient. Osmosis means the process where molecules in a solvent pass through a semi-permeable membrane, which only allows certain things to pass, from the less concentrated side to the more concentrated one. In this case, the water, the solvent, passes through, while the salt, the solute, remains behind.
This equation is only one part of the entire process of reverse osmosis desalination. Everything must be carefully calculated. For example, in industrial desalination plants, there are huge tubes of coiled-up semi-permeable membrane, and there are hundreds of these. Everything from the amount of the semi-permeable membrane used, to the water pressure as it flows through the tubing, the repeat of the process to purify the water even further, and the mathematics of the distribution of all the now fresh water.
Our world does need maths. The water flux equation found in the process of desalinating water is just one extremely specific implementation of mathematics that helps us survive. Think about everything you do and see, the logistics of the food you eat, and even something as weird as the fractal nature of trees. Our world needs maths. Choose maths.